This is a procedural terrain generation pipeline with machine learning inference embedded directly into the engine, integrating Houdini and Unreal Engine 5 to deliver an artist-driven, intelligent terrain erosion workflow. The workflow is designed for Unreal Engine. Using a custom landscape brush panel, the artist paints directly onto the terrain, defining where erosion should be applied. Once the brush stroke is finalized, a single button press triggers the full pipeline. The landscape height map is captured into a floating point R16F render target, passed through a UV correction material to align coordinate systems between Unreal and Houdini, and written to disk. The Houdini asset actor then cooks automatically, running ONNX inference and baking the result back into the landscape in approximately 2 seconds. The terrain updates in place, with the erosion pattern applied exactly where the brush was painted. From there, the artist can continue refining, painting additional strokes, adjusting intensity, and re-triggering the pipeline iteratively until the desired result is achieved. Here, you can see the landmass brush layer directly inside the Unreal Landscape Editor, showing how brush-painted regions map onto the terrain surface before and after the machine learning pass. The brush data is captured per stroke as a height map delta, which becomes the direct input driving the downstream Houdini inference. Switching over to Houdini, this is where the model was trained and where the inference runs. The trained model is exported as ONNX and embedded inside the HDA. At runtime, each input height map is converted into a 4-dimensional tensor, batch, channel, height, width, fed through the network, and the output is written back as a height field. The entire inference runs locally inside the engine with no external dependencies. The pipeline was trained on paired height map images via PyTorch, a raw input alongside its erosion target. 100 pairs of 512 by 512 images were used to train a feed-forward neural network, with Houdini's example-based ML nodes handling dataset generation, pre-processing, and training entirely without custom Python code. The result is a self-contained ONNX model, embedded directly inside the HDA and callable on demand from within the engine.